In this session, I'd like to show you how you can use the graphing calculator to solve problems that involve the central limit theorem. Realize that the central limit theorem is having us compare a sample mean with other possible means. So that should be a key that we see in the question. This question comes from the practice questions in section 9.3. It shares that the mean life of a television set is 96 months with a variance of 225. Given a sample of 76 televisions randomly selected, what is the probability, a key to use normal CDF, that the sample mean would differ from the true mean by less than 1.3 months? So I'm comparing this sample mean with other means. That's an indication I'm going to use the central limit theorem. So to do this, we're going to look at the graph of what this would look like. So it's told us that the mean is 96 months with a variance of 225 months. We'll take that into consideration next. Now we want to know the probability that the sample would differ from the true mean by less than 1.3 months. So we want to see what that would look like. So we want to go out 1.3 months higher than the current mean and 1.3 months less than the current mean. That would give us something that is in between, and we could shade that in to show that it should be somewhere between 94.7 and 97.3 months for our television. So to work this out, we want to use a normal CDF. Our lower bound would be 94.7. Our upper bound would be 97.3. Our mean is 96. And then because we're comparing this standard or this mean with other means, we're going to use the standard deviation that has been reduced because of the sample size. Larger samples mean that we're going to have less variation going on. So we can put this into our calculator. I'll go into the normal distributions. My lower bound, I'm going to put 94.7. Upper bound is going to be 97.3. My mean, 96. And my standard deviation, I can do this right in here. So the square root of 225 divided by the square root of my sample size. Now, if you remember in algebra, you could have made that just one square root, so I don't have to have two separate square roots. I'm going to go ahead and paste that in and work it out. And it says that the probability, the area under this curve, should be about 0.5501 if I round it. So I can go back to my Hawks then. 0.5501. We'll submit our answer. Way to go. So I hope that you can do the rest of your problems in a similar way, finding your probabilities using the area under the normal curve, which is normal CDF on our calculators.